Okay, in this video we're going to take a look at something called piecewise functions. And before we look at piecewise functions, we're going to look at this function in example 1, which is a more ordinary kind of function. And I see it's f of x equals x squared minus 3. And I see there in my notes I'm asked to determine what's the value of f of negative 3 and f of 7 and f of 2. And I remember that in order to find each one of these values, that is, what's the value of the function when x equals negative 3, well, I just take this value here, negative 3, and I substitute it in for x in my function. So f of negative 3 means negative 3 squared minus 3. So negative 3 squared is negative 3 times negative 3, which is 9, and 9 minus 3 is 6. So f of negative 3 is equal to 6. I can do the same thing for any value of x. F of 7, for example, I just take this value of x equals 7, and I substitute it here for x. So that's going to give me 7 squared, which is 49, and 49 minus 3 is 46. So f of 7 equals 46. I do the same thing for f of 2. I take this x value here, x value of 2, I substitute it in to my function here. I substitute it in for x. And 2 squared is 4, and 4 minus 3 is 1. So I can find, the value of the function for any value of x. Well, in example 2, I've got another function, and this function is what's called a piecewise function. And if I try to do the same thing here for this function is g of x. So if I want to know, well, what is g of negative 3? That is, I want to know what's the value of the function when x is equal to negative 3. Well, now I've got a problem because I can see that I've got two different places here that I could plug in this x value of negative 3. Am I supposed to plug it in up here, or am I supposed to plug it in right here? And here's where the piecewise part of this piecewise function comes in. The way this function, the way you would read it, you'd read this function g of x equals x squared minus 3 when x is less than or equal to 2. And g of x equals negative 2x plus 4 when x is greater than 2. So I can see for this value of x, x is negative 3. If I want to evaluate the function when x equals negative 3, well, negative 3 I can see is less than or equal to 2, which means I'm going to use this piece of the function to evaluate g of negative 3. So I don't want to plug this in down here. I want to plug in x equals negative 3 right here. So g of negative 3, I take negative 3, substitute it here. That gives me negative 3 squared is positive 9, and 9 minus 3 is 6. Now if I want to know what is g of 7, well, now my x value is 7, and I can see I don't want to use this top part here because my x value is 7. 7 is not less than or equal to 2. 7 is greater than 2. So 7, this value of x here, I'm going to plug in to this bottom part, this bottom piece of my function, since my x value is greater than 2. Okay, so I take this x value, substitute it here. Negative 2 times 7 is negative 14, and negative 14 plus 4 is negative 10. Now, this one right here, g of 2, okay, well now I've got a little bit different case because now I have to decide, well, now which one of these am I supposed to use? X greater than 2, x less than 2, what if x is actually equal to 2? Well, I can see again, that is, that's told right here. Since x is equal to 2, I can see I'm going to use this top part of the function again because if x is less than or equal to 2, then the function is x squared minus 3. So I take my x value here, x equals 2, and that gets plugged in up here since x is less than or equal to 2. So when x is 2, that's going to be 2 squared minus 4, so that's 2 squared minus 3, so that's 4 minus 3, which is 1, and g of 2 is equal to 1. So this is how we go about evaluating a piecewise function. If I want to find particular values of the function, let's take a look at how we graph a piecewise function. Okay, so here's this same function that we were looking at in example 2. And what I would like to do is I would like to graph this function. And what I'm going to do is I'm basically going to graph each one of these pieces, and then I'm going to go back and I'm going to erase some parts of it. So as you're graphing along with this on your notes, you may want to, when you first start graphing these, kind of, just kind of sketch it in and pencil lightly, because we're going to go back and erase some parts in just a minute. Okay, so the first thing I want to do before I start my graphing, I'm going to erase this part right here, and I know you can't really erase that on your notes, so I'm just going to erase it because I don't need that part for the first part. So out there to the side there of yours, I want you to write this. Instead of having this be g of x equals x squared minus 3, I want you to write this: y equals x squared minus 3. All right, now notice all I'm doing is I'm just rewriting, instead of using this function notation, I'm just writing this as y equals x squared minus 3, because that's kind of the form that I'm used to seeing it when I do my graphing. And this one I'm going to write as y equals negative 2x plus 4. All right, again, it's the same function. I'm just writing it, instead of using function notation, I'm just using y equals notation. Okay, now I'm going to graph this part right here. Y equals x squared minus 3, and I recognize this. That's a quadratic parent function moved down 3 units. So if I take my quadratic parent function and I move down 3 units, it's going to start here, and it's going to look something like that. All right. Now again, on your paper, kind of draw that lightly, because we're going to go back and erase some parts of that in just a minute. This piece down here, y equals negative 2x plus 4. Okay. This I see is a straight line. It's in the form y equals mx plus b. I see my slope is negative 2, and my y-intercept is positive 4. So let's see. How about if I start on the y-intercept? 1, 2, 3. That's right here. And let's see a slope of negative 2. So let's see. Down 2 and over 1. Down 2 and over 1. Down 2 and over 1. And so this is going to give me a line that looks something like that. Okay, so now I've got both of my pieces here in my function graph, and right away I can see that there's a problem, because if I stop right here, clearly I do not have the graph of a function. This is going to fail the vertical line test. So that is where, now I'm going to go back and I'm going to go back to this part that I erased a minute ago, which is these pieces right here. The part where I have x less than or equal to 2, and I have x greater than 2. This is the part of the function that tells me what parts of my graph do I need to erase. Since my function g of x is equal to x squared minus 3 when x is less than or equal to 2, well, x less than or equal to 2, that's right here. Here's where x is equal to 2, right here. And so, since the function is only defined as x squared minus 3, that's my parabola. The function is only defined as x squared minus 3 when x is less than or equal to 2. Well, that's all of these x values over here, which means everything that's where x is greater than 2, I'm going to erase that part of my parabola. All right, so the parabola is only going to come up to right here where x equals 2, and that's where it's going to stop. For my straight line, I can see g of x is only equal to negative 2x plus 4 when x is greater than 2. Well, x is greater than 2, that's all these x's over here, which means I'm going to erase all of the parts of my straight line that aren't where x is greater than 2. So that's all of this part right here, this part here, and up to there. Where's that part too? So now I've got a graph that's kind of a funny looking graph. Let me take this part off here. Now I've got kind of a funny looking graph. My graph is like, it looks like a parabola until it gets to like right here. And then all of a sudden it becomes a straight line, which looks something like that. And in fact, I've got kind of this big gap in between the two. We're going to talk about that gap in just a moment, but for now, we're going to leave our graph just like this, and this is the graph of our piecewise function. All right, now, there's actually one more thing that we have to do before we're finished graphing, but we're going to come back to that in just a minute. First, let's take a look at example number 4. And let's graph this piecewise function. This function is h of x. And I can see this piecewise function is going to have 3 pieces. But I'm going to graph this the same way that I did the other one. First, I'm going to ignore this part right here. And I'm just going to graph each one of these pieces as though they were just individual functions. So y equals absolute value of x plus 4. I know what that looks like. That's an absolute value function. Y equals negative 3. I know what that looks like. That's a horizontal line at y equals negative 3. And y equals square root of x minus 1. And I know what that function looks like. I know what that graph looks like too. That's a square root function moved down 1 unit. So let me go ahead and graph each one of these. And again, I'm going to kind of do it lightly on my paper because I'm going to go back and erase some of it in just a minute. All right, so let's see. Y equals absolute value of x plus 4. That means I move 4 units, my absolute value function 4 units to the left. So 1, 2, 3, 4. So something like that. Y equals negative 3. That's my horizontal line through y equals negative 3. So that one's down here. And then let's see, y equals square root of x minus 1. So my square root function looks like that. I move it down 1, and it's going to look something like that. All right, and again, I see I have the same problem I had before, which is if I just leave my graph like this, it's going to fail the vertical line test. Well, now I'm going to kind of bring back the other part of the definition of my function, which is the part that tells me what pieces of my graph am I going to erase. All right, so this one is y equals absolute value of x plus 4 when x is less than or equal to negative 2. And it's this part of the function when x is between negative 2 and positive 2. And it's this part of the function when x is greater than or equal to 2. All right, so let's see. H of x equals absolute value of x plus 4, but only when x is less than or equal to negative 2. So that's going to be right here. So every part of this function, every part of my absolute value piece, where it's greater than negative 2, I'm going to erase that part. So take all that off. All right. H of x equals negative 3, that's my straight line, my horizontal line here, but only when x is between negative 2 and positive 2. So let's see, that's going to be from here over to here, and then everything over here and everything where x is greater than 2, erase that part. And then finally I've got h of x equals square root of x minus 1, and that's when x is greater than or equal to 2. So let's see, it's going to be this part, but only when x is greater than or equal to 2. So that's from here over. So I'm going to erase everything where x is less than 2 right here. And now here are the 3 pieces of my function. Well, so this, I actually have one last part that I have to do on my function. And let's take a look down there. You'll notice there at the bottom there, for example, number 4, it asks you to evaluate some different pieces of the function. And we're going to do that first, and then we're going to go back and do the last part of the graphing on this one.